Replacement for manual testing. Do I really need it? How should I do it? Should I write my tests first, which we call test-driven development or TDD? Or should I write the application code first? Mosh, I don't know what to test. These are frequently asked questions about automated testing, and in this course, I'm going to answer all these questions one by one. So let's start with the first question. What is automated testing? Automated testing is the practice of writing code to test our code, and then run those tests in an automated fashion. So with automated testing, our source code consists of application code, which we also call production code, and test code. Here's an example. Imagine you have this function somewhere in your code. It's a basic calculate function that takes an input, and depending on some conditions, it returns different values. If you want to test this function manually, you have to launch your application in the browser. Perhaps you have to log in, or maybe you have to do a few clicks here and there to get to a page where this function is used. Then you will have to fill out a form, submit it, and see the result of this function on the screen. And then you have to repeat all these steps each time using different values in your form. As you can see, this is very time consuming. This workflow to test this function may take several minutes every time. Now, to make matters worse, this is not the only function in your application. In a real application, you have tens or hundreds of functions like this. As your application grows in size and complexity, the time required to manually test all the different bits and pieces increases exponentially. So that's why we use automated testing. With automated testing, you write code and directly call this function with different inputs and verify that this function returns the right output. Now, you can rerun these tests every time you change your code, every time you commit your code to a repository, and before deploying your application. With this approach, you can test all the execution paths in this function in less than a second. You can write several hundreds or thousands of automated tests for various parts of your application and run them all in just a few seconds. But there are more benefits to automated testing, and that's the topic for the next lecture. Recently, a student of mine asked me, Mosh, why on earth should we write code to test our code when we can just run the application and see the result? Well, in the last lecture, you learned that with automated tests, you can test your application code on a frequent basis and in less time. But this is not the only benefit of automated testing. The most important benefit is that you can catch the bugs before deploying your application. And this is extremely important because it allows you to deploy your application with more confidence. Have you been in a situation where you finish all the work, deploy your application, left the office thinking everything is working, and then got a call from your boss or an end user telling you that one of the major functions of the application is not working? Then you had to go back to the office, and you thought that was a quick fix, but you ended up staying there until midnight. That's why you should write tests, to reduce the number of bugs that will go into production. Now, note that I'm not saying that with automated tests, you're going to release bug-free software. That's not true. But you can certainly reduce the number of bugs and improve the quality of your software. Another benefit of automated tests is that they allow you to refactor your code with confidence. Refactoring means changing the structure of your code without changing its behavior. If you extract a few lines of a method into a separate private method, that's refactoring. If you rename a method, that's refactoring too. You're changing the structure of your code to make it cleaner and more maintainable, but you're not changing the functionality. When you don't have automated tests, every time you refactor your code, you have to manually test every part of the application that could be affected by your refactoring. And this is very painful because, first of all, it's time consuming, and second, as your application grows, you may forget about the parts that need to be tested. With automated tests, every time you refactor your code, you run your tests and make sure you didn't break anything that used to previously work. And finally, another benefit of writing tests is that it helps you focus more on the quality of the methods you're writing. You make sure that every method works with different inputs under varying circumstances. Next, I'm going to talk about different types of tests. In automated testing, we have three types of tests: unit tests, integration tests, and end-to-end tests. A unit test is what I showed you earlier in this section. You test a unit of the application without its external dependencies, such as files, databases, message queues, web services, and so on. Now, note this keyword here, external dependencies. This is really important, as you will find out shortly. So, these unit tests exercise your code without any external dependencies. They're cheap to write and they execute fast. So you can run hundreds of them in just a few seconds. And this way you can verify that each building block in your application is working as expected. However, since you're not testing these classes or components with their external dependencies, you can't get a lot of confidence in the reliability of your application. So that's when integration tests come to the rescue. An integration test tests a class or a component with its external dependencies. So it tests the integration of your application code with these concrete dependencies like files, databases, and so on. Again, note that I'm emphasizing the word external here. These tests take longer to execute because they often involve reading or writing to a database, but they give you more confidence in the health of your application. Now, traditionally, an integration test is defined as a test that takes a few units or classes and tests their behavior as a whole. So based on this definition, if you test two classes together, some people believe you're writing an integration test and not a unit test, even if none of these classes talk to an external resource like a database. Chances are you have heard this definition before. Now I tell you what, this definition is a great recipe for writing fragile tests that are coupled to your implementation detail. So as you change the implementation of your classes, these tests are going to break and you will end up wasting a lot of time fixing them. Not only won't they give you any values, but they actually slow you down. I'm going to show you an example of this later in the course when I talk about fakes and mocks. If you have done unit testing before and failed, chances are you followed this definition. So once again, a unit test tests a class or multiple classes without their external dependencies. They test a unit of work. An integration test tests a class or multiple classes with their external dependencies. We also have another type of test called end-to-end test that drives an application through its user interface. There are specific tools built for creating end-to-end tests. One popular tool that you might have heard of is Selenium, which allows us to record the interaction of a user with our application and then play it back and check if the application is returning the right result or not. These tests give you the greatest amount of confidence about the health of your application, but they have two big problems. The first problem is that they're very slow because they require launching the application and testing it through the UI. So every test is going to launch the application, potentially log in, navigate to an internal page, submit a form, and inspect the result. It's very slow. The second problem is that they're very brittle because a small enhancement to the application or a small change in the user interface can easily break these tests. So now you know about the different kinds of automated tests: unit tests, integration tests, and end-to-end tests. But what kind of tests should you write in your application? Well, all of them. This is what we call the test pyramid. This pyramid argues that most of your tests should be in the category of unit tests, because these tests are easy to write and they execute quickly. But since they don't give you much confidence about the health of your application, you should have a bunch of integration tests that test the integration of your application code with its external dependencies. These tests provide many advantages of end-to-end tests, but without the complexities of dealing with the user interface. And finally, you should write very few end-to-end tests for the key functions of the application. But you should not test the edge cases with these end-to-end tests. You only test the happy path and leave the edge cases to your unit tests. Now, this pyramid is just a guideline. It's not a hard and fast rule that you need to follow in every application. The actual ratio between your unit, integration, and end-to-end tests really depends on your project. Unit tests are great for quickly testing the logic, like conditional statements and loops. If you have methods with complex logic and calculation, you should test them with your unit tests. Earlier in the section, I showed you an example of a calculate function. Unit tests are ideal for testing these functions because you can quickly test all the execution paths of these functions in less than a second. Manually testing these functions through the user interface takes significant amount of time and is prone to errors. However, not every application has complex logic and functions like our calculate function. You might have an application that simply reads some data from or writes it to a database. In that case, you may need more integration tests than unit tests. So, in summary, this test pyramid gives you 3 recommendations. First is to favor unit tests over UI or end-to-end tests, because these unit tests are the fastest to run and cheapest to write, and they're very precise, so they can pinpoint exactly where something fails. They give you rapid feedback. Second is to cover unit test gaps with integration tests. And finally, use end-to-end tests sparingly, only for the key functions of your application. The right balance is different for each project and each team. At the end of the day, you need to use your own judgment to determine what kind of test you need to write for different parts of your application. To write unit and integration tests, you need a testing framework. There are several testing frameworks out there, but the most popular ones are NUnit, which is one of the earliest frameworks out there. We've got MS Test, which is Microsoft's testing framework built into Visual Studio, and XUnit, which has gained more popularity over the past couple of years. All these frameworks give you a utility library to write your tests and a test runner which runs your tests and gives you a report of passing and failing tests. Which framework is better? It depends who you ask and what their definition of better is. Different people love different tools. So here's my suggestion. Don't get hung up on the tooling. In this course, our focus is on the fundamentals of writing quality tests that give you value. That's what matters. You can always use a different framework as you move from one project or team to another. In this course, we're going to start with MS Test because that's built into Visual Studio and doesn't require any additional steps. But shortly after, I'm going to show you how to install NUnit and run NUnit tests in Visual Studio. You may use either of these frameworks, that's purely your personal decision, but for the majority of this course, I'll be using NUnit because it has a longer history than MS Test, and I personally find it a more elegant testing framework. Now, an optional tool that I highly recommend is ReSharper because it has a faster and more powerful test runner than the one built into Visual Studio. Just to let you know, ReSharper is a commercial product and I'm not their affiliate. You may decide to buy a license or not, that's entirely your choice. What I want to emphasize is that you do not need ReSharper to write or run tests. But I use ReSharper because it's a huge productivity booster. Another optional tool is Writer. If you like Visual Studio plus ReSharper, but you think Visual Studio is too slow for you, then I highly recommend you to try Writer. Writer is basically a cross-platform IDE built by JetBrains, the same company that has made ReSharper. So you have a super fast IDE plus ReSharper with the exact same shortcuts that you use in Visual Studio. In this course, I'm going to record the first few videos with Visual Studio because that's the default IDE for majority of you. But later, I'm going to switch to Writer because that's a lot faster. You can use Visual Studio with or without ReSharper, That's perfectly fine. Your focus should be on the fundamentals of writing good tests and not the tooling. In the next lecture, you're going to write your first unit test. So download the zip file I have attached to this lecture. This is a Visual Studio solution that includes some code you're going to test throughout this course. Hi guys, Mosh here. I hope you're having a fantastic day or night wherever you are in the world. This tutorial you've been watching is actually part of my complete unit testing course for C# developers. And what you see here on YouTube is actually only the first section of this course. The complete course includes more than 5 hours of high-quality content with plenty of exercises and challenges that will help you really master unit testing. In case you're interested to enroll in the full course, I've put the link for you in the video description. And if not, that's perfectly fine. Continue watching as the next section is coming up. Alright, in this lecture, you're going to write your first unit test. So here we have this project called Test Ninja that I'm going to use throughout this course. I give you the link to this project in the last lecture, but if you missed that, you can see it attached to this lecture. So here we have this folder, Fundamentals. Let's take a look at this reservation class. So imagine you're building an application for reserving a table at a restaurant. Our reservation class has currently one property, which specifies the user who made this reservation. Now, in a real-world application, this class can have many other properties, but we don't want to get distracted with too much detail. This is the method we want to test. Can be canceled by a given user. So here I have implemented a simple business rule. If the user is admin or the user who made this reservation, they can cancel this reservation. Otherwise, they can't cancel this reservation, okay? And if you scroll down, you can see our user class, very simple with one property, is admin. So let's go ahead and write the first unit test for this method. Here in the Solution Explorer, I'm going to add a new project to this solution. So add new project. Under installed Visual C# test, you should see this template, unit test project. If you don't see it here, chances are you have not installed Visual Studio properly. So go ahead and download the latest version of Visual Studio. Currently, I'm using Visual Studio 2017 Community Edition. So here we select Unit Test Project and we give it a name. So the name of our main project is Test Ninja, and I'm going to call this project Test Ninja .unit tests. This is the convention we follow to organize our test projects. We want to separate the unit tests and integration tests because unit tests run pretty quickly, whereas integration tests take more time. We want to separate them so we can run unit tests more frequently and integration tests before committing our code to a repository. Okay, let's go ahead. So Visual Studio creates this new project, and you can see here we have a file, unit test 1. It's a simple C# class that has the test class attribute, and it has one method called test method 1 with this attribute, test method. These two attributes you see here belong to MS Test framework. So the test runner we have in Visual Studio looks at all the classes decorated with the test class attribute. Then it looks at all the methods in this class decorated with the test method attribute, and it will run them. So the first thing I want to do here is change the name of this class. So press Ctrl R and then R again. Now you can rename these. I'm going to call this reservation tests because we're testing the reservation class. So the convention we follow is the name of the class plus tests. Enter. Now, similarly, I'm going to rename this method. Once again, Ctrl R and R. The method I want to test is can be cancelled by. Now here we add an underline. We specify a scenario, underline again, and expected behavior. What is this? Let's go back to our reservation class. When writing unit tests for this method, we want to test all the scenarios. What scenarios do we have here? We have 3 scenarios. One scenario is when the user is an admin. The other scenario is when the user is the same person who made this reservation. And the third scenario is when someone else tries to cancel this reservation. So here we have 3 scenarios or 3 execution paths. So there are 3 ways to get out of this method. That's why we call this 3 execution paths, okay? So back to our unit test class. The first scenario we want to test is user is admin. Now, what is the expected behavior? If the user is admin, this method should return true. So returns true. This is the convention we use to name and organize our test methods. Every test method has 3 parts. The first part specifies the name of the method under test. The second part is the scenario we're testing. And the third part is the expected behavior. Now, inside every test method, we have 3 parts: arrange, act, and assert. This convention is called AAA, or arrange, act, and assert. The arrange part is where we initialize our objects. We prepare the object we want to test. In this case, we want to create an instance of the reservation class. So we create a reservation object, new reservation. Now here the reservation class is not recognized, so you need to press Control and period. And in this context menu, select Add Reference to Test Ninja. Okay, so we have a reservation object. The act part is where we act on this object. And that basically means we're going to call a method. That's the method we're going to test. In this case, reservation dot can be canceled by. Now, we want to give it an argument. In this case, we want to give it a user that is an admin user. So here I create a user object and set is admin to true. So this is the act part. Now we want to get the result and verify that it's correct. So I'm going to store the result in a variable called result. And in the assert part, we verify that result is correct. In this case, result should be true. So here I'm going to use one of the helper classes in MS Test Framework that is called assert. This class has a bunch of static methods that we use to make an assertion. For example, if you want to compare 2 objects, we can use r=. We also have other methods here like is false, is instance of type, is not instance of type, and so on. So here we want to assert that this result is true. So we call assert dot is true and pass result. So this is how we write a unit test. Now to run this test, we go on the top. From the test menu, go to run and select all tests. This is what I don't like about Visual Studio, because here we don't have the ability to run only a particular test method like this test method we wrote in this lecture. We can only run all the tests in this project. And that's why I like ReSharper, because with ReSharper, I can run only this test, or I can run all the tests in this class. So it's more flexible. I'm going to show you that later in the section. So let's go on the top. From the test menu, run all tests. And note the shortcut. Remember this so you can quickly run all your tests. This should open this text explorer window. If you don't see that, you can find it on the top, under test, Windows Test Explorer. Okay, so you can see we have a passing test, we have a green mark. You can see the name of our test method and the time it took to run this test. In a real-world application, you're going to have hundreds or thousands of unit tests. So when you run your tests, this window is going to be populated with all the tests in your application. Now let me show you an example of a failing test. So I'm going to go back to the reservation class and create a bug in our code. So here I'm going to return false. Let's say the developer who wrote this code made this mistake. Now, as I told you before, with unit tests, we can catch bugs before deploying our application. So when we create a unit test class and verify the expected behavior of a method, in this case, we are verifying that this method is returning true. With this unit test, we can catch bugs earlier in the software development lifecycle. So back to our Test Explorer window, I'm going to run all the tests again. This time our test failed. So you can see the benefit of unit tests in action. Now here's an exercise for you. As I told you before, this method has 3 execution paths or 3 scenarios. I want you to use what you learned in this lecture and write the other 2 unit tests for this method. In the next lecture, you're going to see my solution. In the last lecture, we renamed this class to reservation tests, but apparently the rename refactoring feature in Visual Studio didn't work properly because the name of the file is still unit test 1. So I'm going to rename this to reservation tests.cs. With this convention, you can easily find all the tests for a given class. Okay, beautiful. Now let's write the second unit test. So I'm going to write a public void method. And by the way, all your test methods should be public void. So here we're going to use our convention to call this method. The first part is the method under test that is can be canceled by. The second part is the scenario. So let's say we want to test a scenario where the same user who made the reservation wants to cancel this reservation. So same user canceling the reservation. Now the third part is the expected behavior. What do we expect this method to return? It should return true. Okay? Now inside this method, we should have 3 parts: arrange, act, and assert. In the last lecture, I added comments to separate the arrange, act, and assert parts, but in a real-world scenario, you don't necessarily have to do this if your test method is short and clean. So in the arrange part, I'm going to create a new reservation object. So reservation is a new reservation. In the act, I'm going to call reservation that can be canceled by. Now here I want to simulate a scenario where the same user is canceling this reservation. So I'm going to create a user object here. And first of all, set the made by property to this user. So this user created this reservation before. Now I want to pass the same user object as an argument to this method, user. Now we get the result and store it. And finally make an assertion. So we assert that result is true. So now with these vertical spaces I have added in the code, you can see the arrange, the act, and the assert parts. Back in our Test Explorer window, let's run all the tests. So we have one failing test, and this is because in the last lecture, I created a bug in our code. So let me change this. Here we return true. Now back to our test class. This new method I created here is not picked up by Test Explorer. We don't see that here. Why? Because we forgot to decorate it with the test method attribute. So that's why you should decorate every test method with this attribute so it can be picked up by the test runner. Now save, back in Test Explorer, run all. Now we have 2 passing tests. Beautiful. Now let's write the last test. So I'm going to start with test method, then public void can be cancelled by. The third scenario is a user trying to cancel someone else's reservation. So another user canceling reservation. What is the expected behavior? This method should return false. So return false. Once again, in the arrange part, I'm going to create a reservation object, new reservation. In the act part, we call can be cancelled by. Now here we want to deal with 2 different user objects. So here I can pass a user object. And when initializing the reservation, I can set made by to a different user object. And finally, we need to store the result here and assert that result is false. So is false result. Now let's run all the tests. So we have 3 passing tests. Beautiful. So I have renamed these test methods to make them more consistent and easier to read. So we have 3 scenarios: admin canceling, same user canceling, and another user canceling. One thing you can see about these tests is that they act as some kind of documentation about our source code. This is another benefit of writing tests. Imagine you join a new team, they give you a new project, and your task is to make some modifications to a class. If that class is properly supported by a bunch of unit tests, you can easily figure out what the responsibility of that class is. Now let me show you another benefit of writing tests. Earlier in this section, I told you that once you have tests, you can refactor your code with confidence. So back in our reservation class, I don't like the way this method is implemented. It looks very amateurish. So I'm going to refactor it and then run all my tests and see if I've broken anything or not. So the first change I'm going to make here is instead of having 2 if statements, I'm going to have 1 if statement and use the logical OR operator. So if user is admin or made by equals user, we're going to return true. Otherwise, we're going to return false. Now, back in Test Explorer, run all the tests. So my tests are verifying that our application is still working. I have not broken anything. I can take this to the next level. So instead of having this if statement here and then return false, I'm simply going to return the result of this expression. Now we have only 1 line of code here. Once again, we run all the tests. All the tests are passing. Our code is much cleaner, and you can see another benefit of writing tests. So far, you have seen MS Test in action. In this lecture, I'm going to show you how to use NUnit, which is my preferred testing framework. So NUnit is not part of Visual Studio, and if you want to use it, you need to install a couple of NuGet packages. So open up Package Manager console. Make sure to select testninja.unit tests in the project drop-down list. Now we need to install a couple of packages. So install -package. The first one is NUnit, And make sure to set the version to the same version that I'm going to use in this video so you will have the same experience. So dash version 3.8.1. Beautiful. Now the second package. Install package. NUnit 3 test adapter. We need this package to run NUnit tests inside Visual Studio, because by default, the test runner that is built into Visual Studio only recognizes MS tests. So set the version here as well. This one is 3.8.0. So it's not exactly the same version as NUnit because these two packages are developed independently, but these two versions are compatible. Okay, beautiful. Now, with NUnit, we have different attributes. So instead of test class, we use test fixture. Now we need to import this type. So press Ctrl and period and select the first item using NUnit.framework. Okay. And instead of test method, we have test. Like this. And finally, we need to modify how we make assertions. So here we have a compilation error because Visual Studio doesn't know whether we're referring to the assert class in NUnit framework or MS test. So I'm going to go on the top and remove this using statement for importing Microsoft unit testing framework. So delete. The compilation is gone. So you can see this assert class has the same API as the assert class in MS test, but here we have a different way of writing assertions, which is more readable. So another way to write the same assertion is like this. Assert that result is true. It reads like plain English. Also, another way is to write assert that result equals true. So we can add a Boolean expression here. Which approach you choose is purely your personal preference. There is no technical differences between these three ways of making assertions. So in this lecture, I'm going to use the second form. Delete and delete. All right, now let's run this test. So once again, on the top, test, run all tests. So all tests are passing, beautiful. So this is how you use NUnit inside Visual Studio. Now, if you use ReSharper, you don't need to install NUnit test adapter because the test runner that comes with ReSharper automatically picks NUnit tests. The same is true if you use the Rider IDE. When you get started with automated testing, a word that you hear often is test-driven development or TDD. Test-driven development or TDD, also called test first, is an approach to build software. With TDD, you write your tests before writing the application or production code. The first time I heard this, I asked, how on earth is that even possible? How can we test the code that we haven't written? Chances are you have the same question. So let's see how TDD works. You start by writing a failing test. This test should fail because you don't have any application code that would make it pass, right? Then you will write the simplest application code that will make this test pass. The absolute simplest. You don't want to over-engineer here. You don't want to design a class diagram with a zillion classes and methods. Use the simplest implementation that would make the test pass. Then refactor your code if necessary. These three steps are the foundation of TDD. You repeat these three steps over and over until you build a complete feature. Now, what is so special about TDD? Well, first is that your source code will be testable right from the get-go. You don't have to make any changes to your code to make it testable. Second is that every line of your production code is fully covered by tests, which means you can refactor and deploy with confidence. And third is that it often results in a simpler implementation. When you start with a big class diagram, chances are you're over-engineering and making the solution more complex. If you write enough code to make all the tests pass, and that solution works, there is no reason to write more code. The fact that all your tests pass means you have fulfilled all the business requirements. So, unless there is a new requirement, you don't need to write more code. And if there is a new requirement, you start by failing tests. So this is TDD. In TDD, we write our tests first, and that's why we call this approach test-driven development. So our development is driven by our tests. In contrast to TDD, or test first, we have code first, which is what you have been doing so far. You start with your application code, and then you write tests. Which approach is better? It depends on who you ask. In theory, TDD is more promising because of the benefits I told you. But in practice, sometimes it can get really complex and it may slow you down. If that's the case, it's better to switch to the code-first approach and write your tests after. In this course, our focus will be on the code-first approach so we can master the fundamentals of testing. Once you master the fundamentals, then you'll be ready to start your test-first journey. TDD really requires a separate course, and I'm not going to talk about it throughout this course. But if you're interested, potentially in the future, I can create a course on test-driven development. Alright, now let me give you an overview of how I have structured this course real quick. In the next section, you're going to learn the fundamentals of unit testing. In this section, we'll be looking at characteristics of good and trustworthy unit tests. We'll be looking at naming and organizing tests, writing some basic unit tests, as well as creating parameterized tests. Once you master the fundamentals, then we'll be looking at the core unit testing techniques. In this section, in each lecture, I'm going to show you an example of a function to test. Each function shows you a scenario that you see in a lot of real-world applications. The following section is all about exercises. So in that section, I will give you 3 unit testing exercises, and you will have a chance to put what you learned in the first 2 sections in practice. For each exercise, you can see my solution as well. Now, up to this point, all our unit tests are for simple classes that don't have any external dependencies. But in the real world, our code often talks to a database, a web service, and so on. So section 5 is all about dealing with these external dependencies. In this section, you will learn about concepts such as dependency injection and mocking. The following section, again, is all about exercises. So we'll look at 3 examples of code that touches an external resource. And finally, the last 2 sections include more challenging exercises. I will show you a snippet of source code taken from a real project. And your job is to write all the necessary unit tests for that code. And of course, you're going to see my solution as well. So in this section, you learned about automated testing and its benefits. More specifically, you learned that it helps you refactor your code with confidence and release software of better quality and with less bugs. You learned about 3 types of tests: unit, integration, and end-to-end tests. And you also saw a glimpse of unit testing in action. You learned how to write a basic unit test in Visual Studio, and finally you learned how to run and debug your unit tests. In the next section, we're going to look at the core techniques for writing unit tests. So I will see you in the next section. Hi guys, Mosh here. So if you made it this far, you seem to be really enthusiastic about learning unit testing. So I highly recommend you to enroll in my unit testing course and don't waste your time jumping from one tutorial to another. When you enroll, you will learn everything about unit testing from A to Z, and by the end of watching the course, you will also get a certificate of completion, which you can present to your current or future employers. So the link to the full course is in the